Number 3, a certain ionic compound is found to contain 0.012 moles of sodium, 0.012 moles of sulfur, and 0.018 moles of oxygen. A, what is the empirical formula? Now, I hope you are noticing that the values that we've been given in number 3 are the same values that we get in the big old long procedure when we start from scratch, when we start from the percent composition. Once we've assumed a 100-gram sample and converted that into grams, and then we convert those grams into mole values. These are those mole values. So we're already at the point where we look through each of these mole values, we pick the smallest number present, and we divide all mole values by that smaller mole value. In this case, it's 0.012. Hope you guys can see that both of these end up being exactly 1. But the moles of oxygen, the ratio is 1.5. 1.5. So you might think, oh, is the empirical formula supposed to be NaSO 1.5? Is that what it's supposed to be? No. Empirical formula is the smallest whole number ratio. Whole number ratio. But Johnson, that 1.5, it's not a whole number. What am I supposed to do? You told us we're not supposed to round. This isn't very close to 1 or 2. It's right in the middle. What do? Well, we're simply going to manipulate this ratio. So it's still the same ratio, but they're whole numbers. And in this case, I can simply multiply all 3 of these values by 2. So this will be 2, this will be 2, this will be 3. So the empirical formula that I come up with is Na2S2O3. Now B asks, is this compound a sulfate, a sulfite, or neither? Well, if it's a sulfate, again, looking at the back of your polyatomic ion sheet, we'll say, all right, a sulfate, messed up, SO4, minus 2 charge, sulfite, SO3, minus 2 charge. Now, if it were true that this S and one of these S's and all 3 of these oxygens were a sulfite, they would have a charge of -2, and that would be balanced out by the 2 sodiums, each having a positive 1, so there's 2 of them, so you get a total of positive 2. That would balance out the sulfite, but guess what? We would have 1 sodium left over, right? Because we only use 1 sodium right here to make that sulfite. Got 1 left over. And that extra sulfur is going to bring an ionic charge of -2. Because remember, this is an ionic compound. These charges have to be balanced within the compound. This is not balanced within the compound. So this means that, no, sulfite was not the case. We don't even have enough oxygens to be a sulfate. So we're going to go with neither. It's neither of them. It's something else.